I'd like to thank Dennis Allen for inviting me to speak today, and I'm have a lot of relatives who have been involved in this scientific method that is used, and we'll try to explain why the existential scientific method was adopted when it wasn't good, and how we know that. So what I want to do is start today with one of my relatives named Henry Lucas. Henry Lucas lived in Great Britain. He was a member of British Parliament, and he was associated with the university. I can't think of the name of it now. Cambridge University. He was associated with Cambridge University, and when he retired, he split his estate up and had a portion designated to create a new position at Cambridge University called the Lucasian Professor of Physics and Math. And so that has been running ever since that time and still being paid for out of his estate. And the many well-known people in the field of physics and mathematics have received it. The second person who received it was Isaac Newton, and he was the Lucasian professor at Cambridge University for 33 years, from the year, let's see, 1669 to 1702. And it was during this time that he did his work on revising the scientific method so that it would be better than the one that the Greeks had put together. You know, they did algebra, and they did geometry, and did a number of areas where you didn't have to do experiments and all kinds of things like that in order to just by observation you could, and using logic, inductive logic and deductive logic. And on the screen here in figure 1, it has the axiomatic scientific method. This is of the ancient Greeks. And so you use inductive logic and deductive logic, and you end up with a theorem or a theory. And so that's how they were doing it. But it turns out that just before Henry Lucas died, or was born actually, we had a major reformation in the Christian church in Europe and in Great Britain. And one of the side effects of that was that the Bible got translated into the local languages of all the European countries, most of them at least, and Great Britain. So people were able to read in English the King James Version of 1611. And when they did that, they read that the Bible says that God is the creator and the sustainer of the universe. And if you think about, well, if that is true, what would scientists be able to detect? And the answer is, well, they should be able to detect it because a universal force was, is everywhere. And so it shouldn't be able to hide it or anything. They should be able to find it. And so one of the tasks that Isaac Newton did was he was trying to figure out how to see and to make your scientific method so you can find the universal force if it exists. So I'm going to go down here and over here on the left, you'll see Newton's empirical scientific method. And so Isaac Newton thought that he should be able to find the universal force, and this is the diagram that shows how his scientific method differs from the Greeks. And you also see at the bottom on the right-hand side, you're using logic to determine if you have found a universal force law. And it wasn't easy to do that, but he showed that by doing experiments, you can find more laws in physics, and you can see if there are universal force law. And Newton did experiments, and he was able to discover the force of gravity, and he was able to discover the force of inertia. And he was able to write down, like over here on equation 1, that's the force of gravity, and equation 2 is the force of inertia. And he was able to write them down. And he put a constant in there called the mass. And if you ask him what the mass was, he said, well, in order to be able to write an equation for the force of inertia and the force of gravity, I had to put a constant in there. And he says, I don't really know what the constant is. I call it mass, but that is what I did in order to be able to write in a mathematical equation form. So that is what he did. And then he did more work, but that was the main contribution that he made, is the force of gravity and the force of inertia. And when he was asked, well, how does the force get delivered? You know, he didn't know. He didn't know how the gravitational force or the force of inertia, it was a kind of an action at a distance with no explanation, rather than being a contact force. So it was not really satisfactory, but didn't know how to do any better at the time. So that was what happened. Well, over time, after nearly 200 years of following Newton's empirical approach to the scientific method, we were able to start working in electrodynamics. And in electrodynamics, the people who were doing the initial work discovered the electromagnetic field, and they realized that the electromagnetic force might be the universal force, and the electromagnetic field might be the spirit of God, and it might be how the force is transmitted. So it's a local contact force, not an action at a distance force. So a certain amount of work was done in electrodynamics, but Maxwell was not able to solve the set of 8 partial differential equations in the scientific method. So what he did is he took 4 of those equations and solved them simultaneously and got a theory of electrodynamics. But that theory of electrodynamics was incomplete. And so we had to, scientists had to make up and develop more theories to supplement it. And the theories that were developed to supplement it were the theory of special and general relativity and the theory of quantum mechanics and the theory of the atom. And so you had a lot of stuff related to electrodynamics that was there, but they didn't, they was incomplete. So they had to add these additional theories in. But many of the scientists who had lived through the Protestant Reformation did not want science to be involved with religion. And so the scientists, what they did was they knew they had the incomplete version of electrodynamics because they couldn't solve, they didn't know how to solve mathematically all 8 of the equations simultaneously. So, but anyway, what they did is they changed the scientific method so that they wouldn't be concerned with the issues related to God. And so that's what you see here in figure number 3. You see the existential scientific method. And the people who developed this existential scientific method were Friedrich Nietzsche and Soren Kierkegaard. And what they did is they also started the God is dead movement. In other words, they changed the way you do science, so it won't have anything to do with God, therefore God doesn't exist. And so that was their goal. And that is what was dominant in the days when I went to college and got my education. But there was another thing that happened. They had problems when they did science this way. And so, for instance, the chemists were able to show that gravity is an electromagnetic phenomenon. Well, that was chemists doing that with their chemical experiments. It wasn't physicists doing it. And so what they did is they introduced in the mid-1960s the postmodern scientific method. And that means you had a separate silo for each area of science. So you have one for biology, chemistry, physics, astronomy, just all the different fields. And the university that we have went from being a university with a universal force that they were searching for to now having a separate department for each field. So we had chemistry departments, we had physics departments, we have biology departments, we have astronomy, we have all these different areas of natural philosophy, which are not going to be united by a universal force because they didn't want that. So that's what they did. And if you were in church in those days and you were thinking about becoming a scientist, the church leaders would tell you, no, don't do that if you're a Christian because that's anti-Christian. And so people, even people like Billy Graham, went around and told people not to become a scientist. My grandfather, named Elmer Lucas, was one of the first mega church pastors in America. And he was in Cincinnati, Ohio. And he he caused people to come and have what we call revivals. And they were having them regularly all year round. And his church, which was a mega church, had many tens of thousands of members. they had just put the streetcar system in Cincinnati, and they built a chapel at each of the major stops on the Cincinnati streetcar system. And then they held revival meetings in those in those chapels. And they were averaging 1,000 professions of faith per month. And the main church was built on one city block of Cincinnati. And the city blocks in Cincinnati are 1/4 of a mile by 1/4 of a mile. And this church had no parking lots, no grass, all building right up to the sidewalk going around the church and the road next to the road. So that was quite a task. And my grandfather married a famous American woman, and her name was Elizabeth Penn. And her ancestors had loaned the King of England a significant amount of money. And when the time came to pay it back, he didn't have it. So he offered them a colony in America, and they accepted it, and that colony became named Pennsylvania. So that colony was owned by the Penn family for a certain amount of time before they converted over to being a state in the United States. And so that was a very interesting history. And my grandfather didn't like people to become scientists under the existential scientific method because it was anti-God. So that was what he did. My father was my grandfather wanted my father to become a revival minister, preacher, whatever. But my father really went the different direction. He became an elevator operator at the U.S. Patent Office. And while he was there, they realized he had a lot of abilities. And so the government paid for him to go to GW University, George Washington University, and get a bachelor's degree, and then go to law school and get a law school degree. And then he went to work for the Patent and Trade Office. And he published a set of 5 books every year showing all the trade and tariff laws in the world from all the countries. And while he was doing that, he was invited to come to Geneva by 7 countries who wanted to create the European Union. And so he accepted it, and he got 3 other people from his office to go with him to Geneva. And to give you an idea of how bad trade and tariff laws were all over the world, and particularly in Europe, he bought a VW microbus for the 4 of them so they could ride together when they weren't working to do sightseeing and stuff like that. And then after he finished in 2 years, he sold that VW microbus, and he sold it for twice what he paid for it brand new when it was 2 years old and had quite a few miles on it. So it shows you it wasn't really good. And after he got the contract to create the European Union signed by the 7 initial nations, within a matter of just a few years, many more nations joined it, and they had 29 nations in the European Union. And then just in the last few months, they had 3 more join. So they're now up to 32 nations. And that contract for the EU was the largest legal contract in the history of the world, even larger than the United Nations and stuff like that, because all of them has shared their, all these nations were sharing their economy, and they were doing all kinds of things together. And like if you had states in the United States, they're very similar to having in the EU having a bunch of states, but they called them countries in those days. And so my father was very well known in that area, and he was involved in knowledge of what was being done in those nations in terms of religion and science and that sort of thing. And then I went to school, and I was not taught any of this stuff, but I was, a little background, I was the National Merit Scholar for my high school in Fairfax County, Virginia. And I competed at the university, at the College of William and Mary, in the physics competition. They had a test that you took, an examination, and then whoever got the highest score in examination would get a scholarship at the College of William and Mary. And I got that. And then the year I graduated from high school, we were in a race with the Russians to get into space. And the Russians had, when World War II ended, they had gone into Germany ahead of the United States and some other countries and taken out all the good engineers and scientists then back to their country where they were using them. And they were building big rockets, and they were putting huge satellites up into space. Their satellites weighed many tons. We put up, with one or two of the people that were left that we managed to get out of Germany, we put up satellites that weighed a couple 100 pounds, but not tons. And the problem with a couple 100 pounds is you couldn't put anything to block the radiation from space from coming in and getting the people if you put a person in one of those. And that's what they want to do. That was their goal, was to get satellites in space, like the International Space Station and stuff like that, and to take the lead. So what they did is they took the best student in in physics and science in each state of the United States of America and territory, and they brought them together the summer after I graduated to Emory and Henry College, or it was a college then, it's a university now. And they got the best teachers from the United States, all the schools, you know, Harvard, Caltech, Princeton, all of those high schools. And they brought them together, and they taught them all of the undergraduate science courses in 3 months. It was very intense. And they wanted to try and create a batch of highly trained scientists. And so I was one of those, and I was one of the top 2 in terms of we had to take examinations in all those courses. And I was one of the top 2 that they had. And when I went to College of William and Mary and told them I'd taken all these courses and who the teachers were, and they said, "Oh, those are the best teachers in the country," they said, "Well, what are we going to do? We don't know for sure what you know. We didn't give you any of the tests, and we didn't see the results." And they decided that they'd let me teach as an undergraduate all of the undergraduate courses, one section of them. And they paid me to teach what they would pay a graduate teaching assistant. And so I did that. And then while I was there, I was able to get a research grant to do original research. And so I applied for a grant and got a grant to study cosmic background radiation and what the polarization of it was. And so I had to build, no one had ever built a polarimeter for cosmic background radiation, but I did, and got it to work, and I made measurements, and I published them in Virginia science magazines, journals that the state of Virginia ran, and received honors in physics as a result of that work. And I became interested in going to the world's most advanced university, which I thought in those days was University of Maryland, because their physics department had, this for my master's degree, had over 300 full-time faculty members in physics, teaching physics. 300. That was more than my whole college I went to had for all the departments put together. 300 faculty. And so I went there, and they had one course that no one wanted to teach. It was physics for pre-med, so over 1,000 students. And you have to get an A or a B or you can't go to medical school. And the people who had taught it before had to give their grades out on the basis of a curve instead of really mastering the material, which they didn't have any trouble with if for science majors taking it. So anyway, they asked me to teach it, and I did, and I did such a wonderful job that they gave me the faculty award for the year for the whole University of Maryland for what I did that year. But I discovered politics in science. And even though when I was defending my thesis, the people who were reviewing it and voting on it told me it was one of the best they had ever seen for even a PhD. And what I did is I measured I built an apparatus and measured the magnetization of nickel, and I measured it from 2 degrees Kelvin to room temperature. And then it turns out there were no theories of magnetization that could explain the data. So I developed one. And but I didn't get a Nobel Prize for that. So but anyway, so I was heavily involved in that. And then I went back to the College of William and Mary, and at the College of William and Mary, at CERN, they had built a series of accelerators, but they didn't work, and they were worried about going into space and being affected by all the radiation coming in that could get into you, even if you're in a satellite, because you don't have a thick enough shielding. So I started working with them there. I was a theoretician, theoretical physics, and they were more practical, but they had a problem. And that is, they couldn't detect the data from all the detectors and analyze it in real time to determine how they were doing in their experiments. So I had been, as an undergraduate, the photographer for the college newspaper called the Flat Hat. And so I made one of the first solid state computers in America. And my solid state computer that I made had 65 80-bit processors. It had terabytes of memory. This is in the 60s. To give you an idea how that compared with the commercial ones, the IBM had just come out with their 1620 first solid state computer. 16 megabytes of memory, not terabytes, and it was pretty slow. And they used punch cards to connect with it, whereas I had the first, what do you call it, first monitor made for me for using that. And by the time I graduated, the super micro, I called it, was made by Micromation, and they sold more of those super microcomputers than all other brands of computers of all types put together. And they were, of course, I replaced, after I graduated, I went to work at NOAA, and I replaced over 500 computer centers that had many computers in them with one super micro at each place. Didn't need a computer center. I put it in a closet and locked the door. And I maintained all of them from Washington, D.C. And on my super micro computer, I ran 48 simultaneous operating systems, and each one could handle thousands of simultaneous users. That was very unusual. And so I did a lot of work related to accelerators and that sort of thing. And I could measure the data that was coming in and see what was happening, which they didn't have any other computer place to do. In fact, at CERN, to do an experiment that we took and did in a few hours in one day, they've taken them a year to do it. That's how poor their computers and their ability to manage was in the scientific field. So anyway, then
we're coming up to the end of this. It'll end automatically. Go ahead.
Oh, okay.
End of session 1. Time has expired.
We sent out copies of 2 papers, 2 newsletters that this presentation is covering. And plus, we had 1 book. I didn't send this out, but you can see it. This is the Universal Force, Volume 1. And it's derived, universal force is derived from a more perfect union of the axiomatic and empirical scientific methods. So in other words, I did what Isaac Newton said we should do, but we didn't know he didn't know how to do it. He didn't know how to solve these equations. He didn't know how to do the work in electrodynamics that was done many years later. So now we have the scientific method called the existential scientific method, which is what is taught in all of our colleges, and the postmodern philosophy, which is using that with separate places, separate versions of it for each field of science, so such as chemistry, biology, physics, astronomy, etc. And they wouldn't necessarily agree with one another with the version of science that they had. And so what I did in this book that I've showed you is I actually took the latest version of the 8 empirical equations of electrodynamics, and I solved them simultaneously. Now, I was able to do that because of my background in mathematics and using the computer. And so I used to had games with people at this school. I would say, can you calculate the value of pi to 1,000 characters, 1,000 digits? And they said, no, I don't know how to do that. And I showed them how to do it. But anyway, I was able to solve these equations simultaneously and get a solution, and then show that the force of gravity is electromagnetic. It's the force between vibrating protons and electrons in regular atoms, and in the elementary particles, it's the vibration of the subparticles that make up an elementary particle, the positive and negative subparticles. And those were not point particles, those were in the shape of a toroidal ring. And quantum mechanics was not a separate field. We were able to do a better version of quantum mechanics than any previous version, just directly from electrodynamics. And that's in the second volume of this series of books. It's the volume 2, which covers all elementary particles. Volume 3 covers all of your atoms and also nuclei. And so we have been able to publish all of those, and they are superior to the other versions, but they don't want the versions of the existential scientific method to be replaced. They want to keep them, and they don't want these others. So if you publish a paper, you get fired. And people who have seen my work and published papers at University of Virginia got fired. At University of in New Orleans, I can't think what it's called, but anyway, they also got fired. And I hated to see that happen to them. Of course, I got fired too. And but we've all had this problem. So if you want to work on this and make something out of it, you have to find a way to do it so that people don't know who you are, and you can publish it, and it just remains a mystery. Now, I worked with some people at the various accelerator centers, like one out west, and
SLAC?
pardon?
SLAC? SLHC?
No, maybe it was at, but I worked at Los Alamos, and I've worked there, and I did a lot of work. I even showed that electrodynamically you can treat patients that have tumors in their brain, and I treated 1,000 inoperable brain tumors in people, 1,000 people, and I was able to cure 990 using beams of negative pions at Los Alamos. And but the medical community doesn't like that because it doesn't use any medications, no medicines, just pion beams. And what happens if you have a negative pion and you bring it in to a person's, through their skull, and slow it down, and it'll stop in the tumor. And then when it stops, and when the electrons, negative pion stops in the tumor, it replaces an electron in an atom, and then it cascades down into get into the nucleus, and then the nucleus comes apart. And that enables you to destroy the atoms that are in the molecules that are in the tumor. And you can see the X-rays coming off, and so you can put a camera up there, and you can see where you're doing all the damage. You can see all the other parts of the tumor, and you could do all kinds of stuff like that. So that is something that is amazing that we're able to do. We're not allowed to do it anymore because it's not based on the existential scientific methods. It's based on the methods of solving the primary equations of electrodynamics, and learning how from electrodynamics to make all your elementary particles, your atoms, your nuclei, your molecules, just all kinds of things that are going on. So we'll mention that to you, and I've had a lot of opposition. I've had to change jobs and lose jobs and stuff like that in my career, but I just thought you might like to know that this is going on. And this method of solution, which I wanted to show on the chart. Let me see if I can get it here. Here I go. Yeah. We're able to define mass. We're able to do all kinds of things. How do you create a magnetic field? All of that stuff within a particle. And so that's there. And then here's the pictures of the building blocks of all elementary particles. I don't know if you can see that, but it's in you have this as a PDF file. And so that shows you how they're made and how the field lines coming out, the Spirit of God coming out from God is going everywhere and supporting all matter that exists there. And you can even do miracles, and you can make lightning and thunder and all kinds of stuff, but that's what we are able to see. And we now understand the theory of elementary particles is predicting all the properties of all the observed elementary particles, and then unobserved, we predicted them, and they went out and found them. They didn't even know they existed. And we also have various nuclei. We've been able to predict all the islands of stability for various nuclei, which no other theory of the nucleus could do. And so there are many, many things there. So the question is, how do we proceed? How do we get the true theory of science accepted when people don't want it, because it supports the concept of God, and that God is the creator and sustainer of the universe, and he can perform miracles which nobody else can do. And that's how we discovered that. So so what I wanted to do was to show you that background, and I'm sure you may have some questions and everything. So if we want to, we can open it up for questions and we'll continue from there. All right.
Wow.
I want to, there was one more thing I wanted to talk about. When the existential scientific method was adopted, let's see if I can find it here. Poincare, Henri Poincare, developed what is called meta theory. And there are theorems in meta theory, and they apply to all kinds of areas, not just physics, but in the area of physics, he had a number of theorems. And those theorems, I'm going to read them to you if I can find them here. Can't find it, but anyway, I'll do it from memory. You can't have two non-linear physical theories in describing the universe. You can have only one. You cannot have two theories that have the same radial dependence, like 1 over r squared. You can't have two that use the same fundamental constant, like c. And so the work that Poincare did falsified all the major theories in modern science under the existential method. And so what did they do? They went around the world and said, every library that has any of these books or publications of Henri Poincare must either destroy them or lock them up and not let anyone see it. Because he proved the theorems, he derived the theorems, and he falsified by logic all the major theories under the existential scientific method. And I went to the University of Maryland, which had the largest physics department in the world, and they had listed in the card catalog some of these books. And I wanted to see them. I wanted to see the proof. They weren't in the library. I went to see the librarian who I knew. And she told me, we cannot let anyone see these. We will lose all financial support if we let you see these books. And so they wouldn't let you see them. And that I had a friend from Argentina, and he was going over to France, where Poincare was, and I had him look and see if he could get it there, and no place would let him see it. And he was a professional in physics, and so anyway, I was really surprised. They knew that this work by Poincare would falsify all the major theories in physics in under the existential scientific method, and they didn't want that. So they didn't want anyone to have access to it. So that's sort of thing going on. And under the education framework, if you've ever been familiar with that, you're not allowed to mention any of this in any education in any college or university in America. And so I didn't realize how politicized science is. And you can't.
So much for academic freedom, right?
Right. Well, believe it or not, when I went to Russia, they liked what I had to say. They wanted to hear it. But in America, when I went to meeting the American Physical Society, same thing that I did in Russia, they said, we're taking away your ability to work at any university in America because we don't want any of that information to be passed along. And so I had to leave the Catholic University, and I've not worked at any university since then, even though I was highly ranked at one time, but because I knew about these things. I didn't have the copies of these books, though, that with the proofs. I would like to see the proofs from meta theory. And so anyway, the role of logic is very controlled, and it's really what is controlling things is politics.
I'm wondering just how you learned about the existence of these things in the first place. I mean, if they wanted to suppress them, they didn't do a very good job. They just stopped you getting the references, but you knew about it.
Yeah, well, I learned about it from other books that reference them, and papers that reference these items. And so I went to the library to try to get a copy of it, and I couldn't. They didn't have they had the books I was interested in the library, but they're in a vault that's locked, and no one, including the president of the university, the chairman of the physics department, no one is allowed to see it. So I didn't like that. And as far as I know, it hasn't changed in 50 years.
Yeah, things have gotten worse.
Yeah. So
we could maybe investigate this further. We could get a list of these books, Poincare, whatever, yeah. And we could just go to the libraries all over the world. Yeah, I mean, you're suggesting it's not just the United States; it's maybe everywhere.
Well, that's the country he came from, France, and there's no place in France where you can get it. And that's like saying, if I publish something in America and you come over from a foreign country, you can't find any place that'll let me see it, even though they might be in every library of every university. So it's yeah, it's not nice. but you can get listings of the theorems that he proved, and I have those. In other words, he didn't show, I don't have the proof of it, but I've got the results of it. And they're, some of them, 4 of them, I think, are listed in this. Yeah, right. In this volume 24, let's see where it is. 24 number 3 that you have a copy of there for the newsletter, on page 11. I've listed 4 of the theorems. These are directly from his work, but I didn't have the, I had people cite that, but I didn't have the proof. I wanted to see the proof. But here's what it says on these 2. No, first of all, the only true theories have to be fundamental theories, fundamental forces. And they say no 2 fundamental theories or forces may have the same radial dependence, such as 1 over r squared. No 2 fundamental theories can use the same fundamental constants, such as c. According to the superposition principle, no 2 nonlinear theories can be fundamental theories when you're describing the universe. Only fundamental theories are true theories. So those were 4 of the theorems. There are many others. By the way, meta theory can be applied to other theories besides science, other areas besides science, and mathematics and stuff like that too. So, yeah, that's and if you cite this stuff, that's when you get in trouble. I spoke at an American Physical Society meeting in Baltimore, and Baltimore, Maryland, and they had Nobel Prize winners and all kinds of people there. And they, when I gave my paper, they said, "Oh, we want you to erase the video of his presentation. We want him to destroy all copies of his paper." And I was just doing something much simpler than this. And so they really do that. And the people who demanded it were the Nobel Prize winners, because I was showing all of their Nobel Prize work was false. No good, no, invalid. They didn't like that.
I've got a question for you, Bill. Let me see if I can bring it up on the screen.
Okay, I see. Hooper-Monstein experiment.
Pages
164,
165 of your first edition.
Uh-huh.
So the first 2 paragraphs are quoting you.
Okay. What? Okay, you're asking a question about that.
Yeah, the
specifically.
3rd paragraph.
Yeah, I see it. He said, but Bill, various thin beams of charged particles could be passed near one of the wire's ends, whose deflection could closely measure whether conductor electrons were either 1, accumulating at that end, or else 2, conductor electrons were moving from this one, thus leaving positive conductor ions remaining there. As the magnets approach the wire, since in either case, that wire's end must have become provided, there was such a robust EMF induced along this long wire as predicted by Hooper-Monstein. Can you scroll down a little bit?
Okay. Okay.
And Wesley. Some of these type questions are answered in my work because the 8 empirical equations that were first discovered in electrodynamics have been improved, and they can explain these things now with the improved version.
Well, but that's saying you're taking theory over experiment. What I'm asking is, if an experiment were done not with a closed circuit, which as you point out is wrong, but with beam of particles and measuring the deflection,
Uh-huh.
then let's see, then wouldn't it be true that you'd have to accept the fact that Faraday's law only holds for closed circuits, and Wesley may be right in his 2002 Scientific Physics, where he uses the fact that the A fields of the two magnets reinforce at the wire, but not sum to zero like the B fields at the wire, in order to explain this experiment.
Yeah, but that's the way you you use the scientific method that I follow, which is Newton's. But you got to realize that when we were developing the electromagnetic force laws, we didn't get them right at the first time. And so experiments like this came along and they were revised. And then those were the ones that I used to get the universal force law, so that I had all the terms. Now, there may still be more experiments in the future that I can't predict, because one of the force laws that I'm using for the 8 force laws is incomplete.
Yeah,
So-
well, that was Wesley's point, is that from his theorem on how A fields induce electromagnetic force in open circuits, if you apply it using Stokes' theorem and apply it to a closed circuit, you get the Faraday Law of Induction, which is part of Maxwell's equations and also part of Hertz's equations. So what if someone performed an experiment like this, not with a closed circuit, but with running a beam of particles past one of the wire ends, close to it, as the magnets approach the wire? Wouldn't that then mean that you'd have to adjust your theory to fit those facts?
If the theory that I have is incomplete, it's because one or more of the experimental force laws that have been measured in electrodynamics is incomplete or false.
Yes, yes, and
Yeah.
this is, my point is here that Wesley claims that Faraday's law of induction is incomplete and only applies to closed circuits based on this experiment.
Uh-huh.
You know, he knew Monstein.
I have made some revisions because of some people have pointed out to me some of the empirical laws that I was using were out of date. They were not good enough to explain all the data. So I made those changes, but they're in other editions, and I don't remember that right offhand.
I see.
I'm getting older.
I know the feeling.
And
Well,
so,
you know, Wesley, if Wesley is right about this, and he has a theorem which, from a corollary, which is Faraday's law of induction for closed circuits, but he uses the A field, and then Stokes' theorem to go to the B field. But the point is that, for example, the electric universe people have a lot of who look at plasmas in outer space rather than gravitational fields. They have lots of qualitative results, but not too many quantitative results. And that too would explain, would be explained by this Wesley's notion that you got to use A fields if you want to look at plasmas, because the particles and charged particles in plasmas, hot plasmas, don't travel in closed circuits. You know, the circuits are open. And also, there's another one. I can't think of it. Oh yeah, the ITER people, ITER, the hot fusion people of about 15 years ago, I think. They claimed that they had hot fusion reactor. I can't remember the name. It started with a T. That would produce lots of almost free electricity, and would with low radiation, so they could get rid of nuclear plants with their extremely radioactive rods and so on. And their resumes of these people in this project were unbelievable. It was like your resume, Bill. And they came up with nothing. They couldn't generate even 1 kilowatt hour of electricity. And if Wesley's right, that would explain why they were using Maxwell's or Hertz's equations or something like that, which had Faraday's law of induction for closed circuits as a part of those equations. And if that doesn't generate to plasma, generalize to plasmas, then their equations wouldn't allow them to do much of anything with hot plasmas. And that, as I say, that's what happened. The inner people struck out completely. And they had no idea why, apparently.
Well, we have had all kinds of technical new capabilities. Like when my children were going to high school, they went to Science and Tech High School, Oxon Hill Science and Tech in Washington, D.C. area. And I wanted them to go to Caltech and to Harvard and those type of schools. And they got a grand prize. They got, first of all, first place at their high school, first place at the Prince-Mont area, Prince George's County, Montgomery County area of Washington, D.C. And then they went to the International Science Fair in Canada that year, and they won the grand prize for the technologies that they were showing how to do. So for instance, we showed how to make something that uses cosmic background radiation, and kind of like in a mode like the solar panel. It looks like a solar panel, but it's not a solar panel. It produces 500 times as much energy per square inch, and it works 24 hours a day, not just when the sun is out. And so that was one of the things that we were able to predict in the area of atoms. And now Elon Musk has patented it. We didn't patent it. And he's making cars.
I've been in touch with you regarding that information on Poincare, right?
Yes.
And I had said to you that I was not able to locate it based on the reference you made in the CNP paper 2016. Regarding what Jan commented in the song, would you be...
End of session 2. Time expired. While we're waiting for Bill, I just wanted to make the point about Poincare's meta theory, that if you have 2 nonlinear equations, that just means that one of them is not fundamental. Not necessarily that it's quote unquote wrong. It's just that there must be a more fundamental way of expressing the idea of one of those 2, or if there are 3 or 4, of all but one of those equations, theories.
What does he mean by a fundamental theory?
That you got it down to the base. You're not, if you have 2 theories that say have C in it, it sort of implies that these are overlapping theories, or you haven't found what's common to both of those theories and reduced it down to the essential foundation, the most fundamental expression of those ideas.
Ian, to your point about why they don't attack, for example, theories that rebut special or general relativity, but they attack these things regarding Poincare. I don't know that I have a good answer other than some speculations that it may have to do with what is perceived as a threat to their belief system. Attacking Einstein doesn't necessarily attack their belief system, because most of the solutions offered for special relativity are just as crazy as special relativity. So they don't see them as threatening. I'm not sure. I think that's a very good question that you asked.
I'll disagree with what you just said.
Okay.
One of the alternatives to Einstein's special relativity is high-level Lorentzian theory. In other words,
Yes.
a preferred frame, and that's not crazy.
No, and I apologize. I didn't mean to say that all of them are. A great many, because there are many rebuttals or people that attack Einstein's theories. But you are correct. There are some that are sensible, but Lorentz is still accepted. So something based on Lorentz is, I guess, acceptable. I don't know. I think that your fundamental question is good, as to why this and not that, and that would be worth understanding.
One thing, maybe they got to Poincare's theories before they were really widespread and locked them up. So now there aren't thousands of rebuttals to Poincare, whereas with Einstein, by now you'd have to silence 3,000 papers. So it's a little bit too late to do that to special relativity.
Bill's interpretation may be problematic for them, very, very problematic. But to me, in the way it's stated, the hypothesis, which I'm not sure I agree with, but the hypothesis seems to be fairly innocuous. It's not earth-shattering. And as Nick says, it probably is merely saying it's not fundamental. It's not saying that it's wrong. So I don't know, it would be a major conspiracy for them to go around and lock things up and stop the president of the university from getting it and all that sort of thing. Just seems crazy. But you've appreciated that, Glenn. You just, obviously.
Yes, I mean, the only other thoughts might be that Poincare's arguments are absolutely, from the philosophy of science point of view, fundamental. They're about how you think and how you analyze the bigger university view and not just the physics department view of things. So whereas, arguments about special relativity, those all stay over in the physics department. So they're not as broad and wide reaching as Poincare's fundamental, critical thinking concepts are, that they don't want to get spread around. That's the only other aspect of it that maybe makes some sense to me.
Let me comment on that. I think that in Poincare's thesis, he was including God and a single force. So that's why they didn't want, there was a religious aspect of it. Now, I would differ with you about Einstein's theory has stayed within science. A lot of people say that the relativity theory and non-absolutivity aspect of that is so important to the academic left that it has to be preserved. But maybe that's at a lower level than actively including God in understanding science and logic.
Fair enough.
The relativity theory is one of the fundamental philosophical foundations for leftism. There is no absolute law. Everyone can have their own personal morality. Everyone does what one chooses to do.
Whatever about the individual views, I mean, Einstein obviously has been made a sort of a saint, but Poincare hasn't been made an ogre. If they were so much against this one theorem of his, that he'd destroy the whole of their own thinking, they might have made him into an ogre. But I mean, I have his book, Science and Hypothesis, and you can get his writings in other ways, and he's considered quite highly, generally by the establishment.
But
Yes.
not the meta theory.
Yeah, exactly. So because of this one meta theory, which
Yeah.
we can't really get hold of, it seems to be locked up. But everything else, he says, it's fine. There's nothing wrong with him, and he's taught in modern philosophy schools and so on. This question is all.
Well, we'll ask Bill if meta theory brought in God to the discussion.
Academia is, especially in the sciences, which I'm familiar with, is like a herd of cattle. Not that they're stupid like cattle, but they all sort of work together, and you can't get them moving. But if you do succeed in getting them moving, they stampede. There's no telling what they'll do. And so it's like they're herd animals. You start talking to them, and then you get into an area where they know they shouldn't go, you know, and they start acting strangely, making up strange excuses. You know, you can't pin them down. They're not interested in truth. They're interested in being with their peers and hanging with them. And to get them moving is hard, but then when you do get them moving, to get them to stop again, it's even harder, apparently. And
Well,
so as I told Nick in a phone call the other day, there's got to be a black swan event to break up this logjam that Bill was talking about.
No, I don't see it here. But anyway, I have published over 100 papers, and I'm doing 5 books. So
Wow.
I have quite a lot to do. And on the books, when I update them, if I get updated information, like if you show something that's wrong with my work, I will try to fix it and see if I agree with you that it's not good. But that's what I do, and I'm in my 80s now, so I need to worry about memory loss and stuff like that, you know.
Yeah.
Yeah.
Maybe instead of trying to convince academia, you should try to interest the entrepreneurial world to take advantage of
Oh, well, I
this
did that.
Oh.
And Elon Musk took advantage of it.
Oh.
And became the richest man in the history of the world.
Oh dear.
Have you seen in January of 2019, he invited 1,500 companies to come to a racetrack out west and to see 2 new technologies and to determine if they want to use those in their business. So when they arrived at the racetrack, he then brought out a Tesla car, and it looked like a regular Tesla car, except that on the roof, it had a 1-foot square thing that looked like a solar panel, but it was a cosmic radiation energy background panel.
I wish you would elaborate on that.
Okay, so anyway, this produced enough power.
Yeah.
When a driver got in the car, the car had no batteries. All it had was this source of energy from this cosmic background radiation energy panel, and it was just 1 foot square. And he was able to make the car go from 0 to 400 miles per hour in 6 seconds. The second day, he brought out a car like the first day, except this car had no wheels and had no motors in it. Just had the cosmic radiation energy panel, and it used inertial propulsion, because nobody knows as much about inertial propulsion as you can get from the work that I've been doing. And that inertial propulsion he was able to also go on the racetrack from 0 to 400 miles per hour in 6 seconds. But then he took 3 volunteers and said, we're going to take you around the world in 4 hours. And they got in and they had their cell phones and everything there and taking pictures, and they went, the car rose up above the ground and went all the way around the earth. And then when they got back, he said, SpaceX is using this technology to put satellites into space. We're putting 8,000 low altitude satellites up in space and using this technology with our energy panel to keep them in the right orbit, which most other types of organizations can't do. And anyway, he said, if you want to use this in your company, you must give me $1 billion each company to use it. And by the end of January, he had received $1 billion from 1,252 companies. So that's just two areas of technology: inertial propulsion and a cosmic background radiation energy panel. And and those were related to a high school science fair project, which, by the way, NOAA provided the judges for the grand prize at that international science fair, and NASA was really impressed with it. Yeah, there's all kinds of new technologies that can come out of it, and a lot of money can be made. But I want one of the cars that runs on it. The car that uses no wheels and no motors, just has the technology of the shell of the car and the lights and the GPS and all that kind of stuff, you know. And you can take that one to the moon or to Mars, and you don't have to worry about it. We don't have to have roads anymore. We don't have to have stoplights and stop signs. The car can be programmed to just jump up and down, so when you go through an intersection, you don't hit anybody. And the cars can talk to one another. And Elon Musk is putting up 8,000 low altitude satellites to handle all this stuff. And they've gotten approval from the state of California. The state of California has tested these cars, and they say it's 10 times safer than any other car we've ever tested. And, you know, and you don't have to pave roads anymore. You don't have to buy gas or any fuel. You don't have to recharge any batteries. All that stuff's gone. And as far as we know, the cosmic radiation background energy panel will last a lifetime or longer.
Well, maybe that explains. I've been on YouTube, and for a month now, Musk has been installing energy panels on your house for free, just to test out the new system. I wonder if he's testing out these CBR panels. Yeah.
You can get an energy panel that will fit in a briefcase, and you can plug it into your house, and it'll run everything in your house.
Yeah.
And I'm in a member of a co-op here, and I'm trying to tell the people at the co-op who run the co-op, we could use this because we don't have to keep putting in new towers and telephone poles and all that kind of stuff. We don't need that, and we can do everything with just one of these panels, and they can put it in the basement, or they can put it on top of their car, or whatever they want to do, you know. And you can go on a trip with it, and then come back and put it in your house, you know. And so you only need one, and you can do quite a lot of things with it.
Do you have an estimate as to how much more powerful it is per, square foot than solar panels are?
500 times
Yeah, that's what I've heard. Yeah. Wow.
Yeah. And you don't need any batteries, and it was 24
Yeah.
hours a day. So that's why you don't need any batteries. It works, the background radiation
Yeah.
is all the time.
Yeah. That's worth waiting for.
Yeah, it is. And the fact that if you don't have to do roads anymore, I mean, you make the roads in your GPS, but you don't have to actually pave them. It will save a lot of money because for transportation, and you get plenty of energy to power all kinds of things just by moving the panel around. And so that's the two most interesting things that I've seen. And but he's now got, SpaceX has gotten a contract to do all of the space projects that we're doing in America.
One might be concerned, of course, following our earlier conversation, that if such fundamentally new inventions destroy, the existing infrastructure and the existing interests and the existing facility to make money and so on, that they might be subject to attack, maybe by keeping things in libraries, but then even more sinister things, physical attacks by the existing powers that be and so on. Perhaps this has happened in the past with all new inventions, and ultimately actually the authorities or the various interest groups realized that things were changing, and then they adopted the technologies themselves. But perhaps in the earlier years they had sabotaged them.
Well, I'm sure that things like that could happen, and there's a lot of people are don't want you to be making all the money. I mean, you realize how much money you can charge for a car? It costs you a couple $1,000s to make, and lasts a lifetime, and can go to the moon and Mars and all that kind of stuff. But you have to wear a spacesuit because the car is not that secure in terms of holding the atmosphere and air in it. But yeah, and they demonstrated that to the executives for 1,500 companies, and they were impressed. They put up 1,252 of the 1,500 companies that saw it put up a $1 billion the first with that January of that month that they saw it, and that's a lot of money to put up, and just so you can use it. But I think they saw if they didn't use it and someone else used it, they would lose. So they had to do it in order to stay alive as a company.
Bill, I'd like to ask you a question about the Newton scientific method.
Uh-huh.
I've read criticism about it, not in the line of thinking that you presented, but in terms of the Newton system was really built to study a closed system. And as Kent Mayhew has shown about thermodynamics, because thermodynamics took the closed system paradigm, they went down the wrong road. Whereas when he looked at it from an open system point of view, and talked about, what's the effect on the closed system in terms of lost energy going out beyond the bounds of the closed system. The resulting theory was simpler, predicted things more accurately, et cetera, et cetera.
Uh-huh.
So do you think that's a valid criticism of the Newtonian?
Well, I'm not actually aware or informed about thermodynamics and Newtonian work. I think it wasn't thermodynamics developed after Newton died.
Yeah, but they took the closed, the closed system point of view. They looked at engines, but they didn't, and they came to the conclusion of entropy in the second law. Whereas if they looked at the lost energy that went out beyond the closed system, those two constructs were obsoleted, and the whole area of thermodynamics became much simpler. and as I say, explain things more accurately.
Well, they were able to explain, we were able to explain with this approach of Newton to what caused the Earth to expand and to crack and to have volcanoes and stretch marks and everything in the bottom of the ocean. So as far as I know, the people at in the Navy who did the work on the ocean, what they did is they took all the sonar logs of all the ships that had been used by the military, and they put them on a computer system, and they were able to make maps of the bottom of the ocean, and they could see where continents used to be connected together and all that kind of stuff. And that was quite impressive. But no other theory, as far as I know, was able to explain why the Earth is expanding instead of contracting over time. The Big Bang theory would have it contracting, but it's the Earth is expanding, and that the force of gravity is getting weaker over time, and that's what causes the expansion. And it's getting weaker because the mass of the Earth is determined by the vibration of electron, protons, and atoms and nuclei, and so when that vibration loses energy over time if it's due to electromagnetic effects. They feel it's
There's a book that I recommend, Lost in Math by Dr. Sabine Hassenfelder, that explains for the part about particle physics, how it got completely off the right trail. And there's been no major breakthroughs now for at least 45 years. And this book is inexpensive, and it's very well written. I gave it to my daughter, who was a criminal justice major in college, and became a federal agent, and got married, became pregnant, and decided to raise a family. And she was able to understand it. She hadn't taken any physics since high school. So I really, let me show it again. Lost in Math, How Beauty Leads Physics Astray by Sabine Hassenfelder. And I really recommend this book, just so you can, I think it'll help you understand what Bill has been saying about quantum mechanics and particle physics. And it's just an excellent, excellent work. I mentioned another book I bought when I was in high school, Pilgrimage to Earth by Robert Sheckley, who was known as the Franz Kafka of science fiction. And on the front of the book, it has the following statement: a fresh and daring insight into the man of tomorrow, a man with the power of a god and the sudden whims of a reckless adventurer. And I didn't know it at the time, I was only in high school, but that was the mindset of the academia when they, as Bill pointed out, they rejected Newton's scientific method because it was too religious. They were thinking of themselves, especially after the 50 kiloton hydrogen bomb went off, as just what it says, a man with the power of a god and with the sudden whims of a reckless adventurer.
End of session 3 and the end of the talk. Thank you very much, Bill Lucas, for many mind-expanding ideas, and thanks to all attendees.